We're excited to have Rick for his keynote presentation titled Cyber Threat Mitigation in the Cloud. Rick, thank you so much for being here with us today. Welcome, and over to you.
Thank you, Michael. Happy to be here. Hello, everybody. Thanks for joining me on my little session today. We only have 30 minutes, but it's a really, really meaty topic. And so some of these, each slide I only have like 5, or I could do whole 1-hour sessions on any of them. And so we're going to talk about cloud security. Cloud security is one of my favorite things. We're all moving to the cloud. I'm very active in the Cloud Security Alliance. I'm going to reference some of their material here. But, there's also the understanding of what's different about the cloud. I talk about this with a lot of people because there's a lot of things that we've traditionally done over the last couple decades in data centers that don't apply to the cloud, and really not everyone understands what it is. I'm on the board of my local Cloud Security Alliance here in Charlotte, and some of the things that we need to kind of do is socialize the basics of what does it really mean. It's not this magical thing out there in the ether. And so I have here on this first slide just kind of what makes the cloud different. So first bullet is just, this is a definition of cloud. The fact that it's on-demand, self-provisioning, and elastic, meaning that I don't have to open up a box, set it up, plug it in, turn it on, install something on it. I can just on-demand click a button, click some radio buttons, and it just spins up all magically by itself. It can also be provisioned by the user and not having to require somebody to do it. And then it can be learned to be able to, set a policy where if he gets to 80% capacity, you spin up another one, or if he gets 30%, you spin down one, that kind of thing to make it elastic. So you're only paying for what you use for instead of having to overbuild like we used to do, 15 years ago. It's often outside of the perimeter protections, meaning that, we have traditionally put together, and I know, perimeter hasn't been around a long time and we've always VPN'd in, but, now this is a whole different infrastructure that now people outside my infrastructure can go to without even having to go through my corporate infrastructure at all. And so my traditional security controls may not apply because it's meant for an infrastructure. The main area also is then the shared responsibility model, and I'll have a slide about that, so I won't dwell on it now. Heavy use of service accounts, meaning it's not just users logging in, but because everything is API-based and system-based, that you have lots of shared accounts, which have opportunities for risk. A lot of segmentation, micro-segmentation as kind of people call it, but more virtual networks, so they're smaller pieces. Traditionally large enterprises and data centers are kind of flat. Once you get one way, you can go everywhere. Here, everything is very segmented for lots of reasons, and a whole other discussion about that. The dynamicness of it, and the fact that it's not just we're setting things up and leaving them there. They will spin up and spin down as needed. When you talk about advanced applications, there's some things that workloads that may come up, be on for 2 minutes, do its job, and then come back down again. And so that makes it very, very dynamic and a lot tougher from a security standpoint, though actually an advantage because then there's a small window of opportunity from an attacker standpoint. And then finally, it's connecting with everything. It's all APIs these days, and that everything is connecting with everything else. And a lot of these connections may be with third parties, platforms, or other things. So let's talk about the shared service model. And like I said, it could be a whole presentation just on this. And I'm not going to spend a lot of time on it because I only got 30 minutes. And that is, when we talk about cloud, there are 3 primary types. There's the infrastructure as a service, which everyone kind of understands as what AWS or Google or Microsoft will have, just some bare metal that you put your servers on, you put your applications on, and you do things with. And that represents the green part here. What the cloud secure service provider would do would be responsible for that underlying hardware, the underlying building that it's in, and all these kind of core components and infrastructure to kind of keep that up and running. Then we have a platform as a service where on top of that, there might be just a basic application, Oracle as a platform being an example of that, some Azure as being another one, that, they have the underlying platform as a software that you'll be using, but then you'll be kind of accessing it through different APIs or through different connections and different integrations, things like that. And then probably the most common one, though, particularly for many organizations, is a software as a service. And these are things like Salesforce and ServiceNow and Workday and even I would say Microsoft 365 is a software as a service, because it is a complete software package that you are just kind of providing your credentials and your data and you're using it. You're not responsible for all of the keeping it up to date and you know, the care and feeding of it, as it were, and patching it and things like that. And so this is kind of when we talk about the shared responsibility model from a security perspective, I would not have any control over that. And so, like, for instance, with software as a service, one of the things that I have control over is that interface and those connections into it. And so we kind of, you know, there's the concept of that are kind of called low code, no code, and that these are like Salesforce. I may be doing some kind of UI adjustments and I'm kind of, you know, connecting to certain databases and things like that, but I'm not really like writing anything. It's kind of like a GUI, you know, type of setup. And often, unfortunately, those are done by the organizations, which may be like the sales organizations kind of setting up, or they hire somebody outside to do it. And if you are an organization that has normal greenfield development, you may not even be part of that, because that's, you know, the business is responsible for that. So being able to do that, when we look at some of the threats to each of these different levels, you know, that's probably my favorite one that people are not really paying attention to. So when the Cloud Security Alliance just a few months ago, we came out with their top 11 threats to cloud. And when we talk about them, you'll go ahead and look at them here, and you see a lot of them is really just configuration and vulnerability management. I mean, it's not, you know, back 12 years ago, I was on the Open Data Center Alliance when that was a thing, on the board of that for compliance. And the things people worried about were this multi-tenancy, and it's like, oh, how are you sharing my information with other people? And how do I know the cloud provider is going to be trusted, that they won't look at my data? And at the time, the biggest risk was, how do you know the service provider is not going to go out of business and then all your data is stuck and you can't get it out? You know, so the things that people really, and these are from surveys and these are from reports of like what real vulnerabilities are. Let me take a pause, take a look. We have a couple questions already. I mean, we're only 7 minutes in, got a question. How would you recommend an organization increase the security operation visibility in the cloud? I'll be talking about that. What are the most important cloud security challenges today? That's what this talk is about. And if there's a specific one, then I can talk about, but this is probably like the main ones I would say. 5 years ago, the great thing that I would say was, don't leave your S3 key in an open production, in an open development environment to be seen, a public development environment in your code. So when I talked about service accounts, you kind of have the account that then spins things up or spins things down, and that's in a development repository with the code, and that's a public code repository, and that key is visible. Immediately, within seconds, people are going to start spinning stuff up on our behalf and doing, run a botnet or do some crypto mining or do some kind of DDoS against it. That was like the main one. It's still just user error. A lot of it is just user error if you look at this list. And the other question I have up here, what are some things to consider when vetting vendors for cloud partnership? Oh, a whole other discussion. I'll touch on that in a little bit later. So when looking at these, like I said, you can categorize them in configuration and secure interface with APIs, misconfigurations and change control, insecure system vulnerabilities and things like that, misconfiguration of serverless containers. So some of these are very specific. The bottom two are kind of like the outcomes of these, so having your identities that are like either weak passwords or exposed passwords will allow organized crime to get in. Insecure interfaces, if you do security operations and you're watching your APIs, people are going to be banging them all the time to figure out what things it's looking for to see if they can get access to certain things and what it can access. But the one I want to drill down, and again, each of these could be a whole presentation itself, is the insecure software development. And that's my next slide. And this is where I talk about, and I put over here, just like at the last minute, I've decided to put in a pipeline. So CICD, if you've probably heard that term before, a pipeline is a continuous integration, continuous deployment. That little black box that's down here on the bottom right is what a CICD pipeline. Before it used to be, design, build, and run when it comes to application. Then it's like integrate, orchestrate, and collaborate. And instead of, just kind of like, and we've also evolved into this pipeline of being able to integrate into the cloud with the security and into the development. And so what happens is the developers kind of transition into the infrastructure, where before you had an infrastructure team that would stand up a server and the developers would then push code to the server. Now, infrastructure as code within that development, within those programs, are going to be spinning up the infrastructure and as part of the code. And so they kind of crossed over into, so this pipeline that I kind of see down here, these 5, 6 steps, or 7 steps, cross into the infrastructure. And so it's not just I have a code, I have an application that I'm building, I push the application up, but I'm also managing the infrastructure and maintaining that infrastructure as it goes forward. So in protecting this CICD pipeline, which transition into the infrastructure, we have security stack, and that's what's on the left. And so this is a traditional thing. And this is like my list that I came up with, as I talked to lots and lots of vendors that are in each of these different areas. And so I kind of see where they all fit together. And so we start off in an SDLC process, or now it's not the system development lifecycle, it's the CICD pipeline, as we call it, is threat modeling. Been around for 17, 18 years. It's a really great way to kind of look at a design and figure out all of the different entry points, all the access levels, and what threats you could have. So try to secure it right from the beginning. Then there's static code analysis, where the developers will run a tool against the code and make sure the standard like OWASP top 10, SQL injection, cross-site scripting, all those kind of things are not present in their code before they get run. Then the dynamic code analysis. So once the code has been, compiled and released into like a development environment, then they'll kind of look at a more dynamic way while it's running. Am I able to, release sessions? Is there some, URL rewriting that I may be able to get into and do something and look for weaknesses there? Then there's like an application architecture insight, and this is kind of a unique little phase in between this and we get into the posture management of the infrastructure, and this is where we transition. And the application insight is kind of like what the bill of materials is. It's the map of like what components are being involved. It kind of shows you what are the APIs that are called, whether the data sources are pulling from, what are the credentials that they're using, and how everything all kind of fits together to be able to identify weaknesses. While the application is running, you have these RASP tools, which I don't remember what the acronym stands for, but it's like application runtime security protection, maybe something like that. And so what that's doing is, as things are going, if something in the application is happening that may be insecure, it'll flag it and then maybe even just drop it and restart it if necessary. Then we transition into the infrastructure posture management tools. These are ones that are traditional like cloud security tools. Tools like Orca, Wiz, DAS, Sysdig, Bionic, Prisma, these are the ones that like really do the heavy lifting. They sometimes get categorized as vulnerability management because they're technically that, but they also are posture management, and some of these tools are getting smarter, including some of the static code tools of looking at that infrastructure as code, that they're reading the code and saying, oh, there's vulnerabilities in infrastructure as code. And the intent is to try to get back to the root cause, because when these temporary workloads keep coming up, in containers, you don't have like 100 vulnerabilities, you have 10,000, because you're spinning up so many and then they spin down and then you're like, oh, there's a vulnerability, but then it gets reintroduced, so you got to get to the root cause. That's the important part. Permissions management, as I kind of mentioned before, when we talk about secrets, API security, which is a core because everything's APIs. And then I mentioned at the very beginning, the no code, low code. I have a couple more questions here. All these things, is there one thing to target first? If you're doing your own development, I would focus on the code testing and make sure that you don't have weaknesses in the code before you go. If you're not doing your own development and you're just managing just workloads in the cloud, I would go with a posture management tool to be able to kind of see what's going on in real time. I'll get into the security operations challenges overall with the cloud, but that would be my 2 answers to that. If you are not doing either of those things and you're just dealing with software as a service, I would go for like a no code, low code kind of thing. One on top, Zenity is a company that does that. There's some others that help you in managing the security of those. And then if you do like integration of things, and so it all depends on your business and kind of what properties you have in the cloud and how you use it, which ones you would focus on. Another question is, how many of these top threats mentioned can be mitigated by internal controls, and there any prioritization that should occur? Perfect question, because it leads right into my next slide, which I need to be on the thing to be able to switch, is to be able to how do we apply controls? So CIS Critical Security Controls is a control framework, and this is where we can apply controls. So as I said, that I work a lot with the Cloud Security Alliance. I am on the editorial panel of the CIS Critical Security Controls, and I'm part of the group, the committee who develop And the last, for the last 10 years, all the different control versions. This is from version 8 that we released in March of 2021. And we had gone from 20 to 18. If anyone didn't know, it was not the 20 controls anymore. It's the 18. We got rid of 3 and we added 1. And these are they. They apply to the cloud because these are like the fundamental things. We did this to kind of look at what is the hygiene or the basics you need to do that everyone needs to do, no matter how small, medium, or large they are. And if you can do it down, you can go to CISsecurity.org, download a free copy of this, and play along at home, and you can look at all the details of it. You'll see that we have for each of these different controls, there's anywhere from 5 to I think the biggest one's like 14 safeguards that are included. There are specific little things to look at in each of these 18 controls. And we highlight them based on, which implementation group, 1, 2, or 3, small, medium, large, or immature to very mature. So when we talk about the mapping over to the cloud, and we're actually like literally in the process of doing a map to the cloud security, working with the CSA. So my worlds kind of come together and overlap when we talk about these things. We start at the basics. So again, since 2009, when they were called the Consensus Audit Guidelines, number 1 has always been asset management. You can't protect what you don't know. What's great about the cloud is nothing happens without being logged. You know everything that's going on. You may have a hard time finding logs and getting the logs, but it's there if you know where to look and be able to get them. So asset management is really, really easy in the cloud for 1 and 2. Data protection, also fundamental. It becomes a challenge. It really is, because your data may be in multiple different places, and your data could be, not just from a replication standpoint, because the whole beauty of the cloud also is the resiliency, that if a section goes out or some goes out, you have other ones over here. It's also very dynamic as your things may move around in different platforms. But knowing where your data is very important. So there's guidance on like data governance, of being able to understand what data is protected. Also on the cloud, you probably have more development, test, and staging environments. And so where, number 1 rule in development application security is don't put production data in development. And you may have multiple development environments and maybe staging or maybe pre-prod environment to be able to manage that. Because unlike the old days where I had to, literally unbox a computer and put it on the floor and plug it in, turn it on, and install it, I can just, press a bunch of buttons and spin up new environments, and it makes my life a lot easier. And so I'm not going to go through all 18. Don't worry. I'm just doing like the top ones. And so going back to question 5, the previous question where it's like, is there a priority? This is the priority. We reprioritized. Like in version 7, data protection was 13. And we moved it all the way up to 3. So if we talk about asset management, data protection, configuration management, identity management, and vulnerability management, those are the top 5 things, and they represent the first 6. Same thing applies to the cloud. Nothing unique about that. A couple of questions. Any particular consideration or advice for companies that deal with crypto and blockchain? That would be the data protection part. So it's just like with anything, just like picking your bank, make sure you have one with a good safe, because if so a reputable place where you have it, or if you have backups of your blockchain or blockchain's kind of distributed anyway, but of your crypto widgets, whatever you're kind of managing, whether it's Bitcoin or otherwise, make sure it's really, really protected. You can do that in the cloud, certainly, and that's with the same things here. Make sure that you have good identity and protections and strong authentication and good, encryption and limiting access, and be able to monitor and say if something goes wrong to be able to recover from it. Do cloud service providers often offer hardware security modules to manage crypto? Yes, they do. So when managing from a crypto, there is a hardware security module that, the cloud provider may have it. There may be a third party that may have it. There may be some escrow group that may want to keep that, or you can kind of do your own. So yes, that is certainly something that is part of this whole chain, because managing cryptography is one of the tenets in being able to protect your data, as well as kind of manage your secrets, meaning your credentials and things like that. So I'll just quickly kind of go the rest of them. You can see, log management, email and web protection is kind of less relevant in the cloud. Data recovery, certainly, and which is an interesting one, because we used to call it referred to more as backups, but it's really about recovery of the data, not the backing up the data. The recovery is the important part. and then some of the other ones as we go through. Another question here, what tools are used to perform static and dynamic security testing for the code? So there's a number of things in the, some have been around for a long time. So static code analysis tools like Vericode's been around forever, Checkmark, Sneak, Synopsys. These are all tools that have many have been around for a while that do the static code analysis. When you go to dynamic code analysis, it's like your traditional vulnerability management tools like Nessus and Rapid7. There's also White Hat Security, and there's some specific application-specific ones. But depending on what your requirement is, and really it boils down to, again, how you're going to fix them. It's easy to find problems, it's harder to fix them. So make sure you have a process. That's the number one I kind of coach people on, is have a process for being able to remediate. And that process may be different whether you find a vulnerability in a container that's on the infrastructure, because it might be a container that came from some immutable image that was kind of pulled over as part of the infrastructure as code, and that the infrastructure team has to fix that image, and that may go to a ServiceNow workflow, as opposed to something that was a bug in the code itself, which may go to Jira. I mean, I probably bring it up every week that need to be intelligent of where the workflow is, of who's going to fix it, because it's easy to find stuff, it's hard to fix stuff. Make sure it makes the people as easy as possible to be able to fix the things that they need to fix. So my final slide here, let's see, another question. What's the difference between private and public cloud in terms of security? In terms of security, nothing. In computer responsibility is the main thing. So the private cloud is pretty much the infrastructure as code, the infrastructure as a service that I mentioned on the very first slide, which is you have the underlying hardware. You have the building, you have the hardware, you have the underlying operating system that kind of stages whether it's going to be virtual machines or containers or whatever you're going to do. And you are now responsible for that, as opposed to offloading it to somebody else. But how you secure it would be the exact same. There might be certain things that people have for, like, if you're really, really paranoid, to have certain requirements for, and even like with very sensitive information, like all the cloud providers have like a FedRAMP version of their cloud that has a little bit more security certification for government, for hosting government data. I'm getting much older. 20 years ago, I used to run ethical hacking teams, and people used to say, like, which is more secure, like Windows or Unix or whatever. And the answer still applies here, is like, anything can be secure if you commit to it. It's, so my answer to that question was, it depends on the administrator. And so if you commit to it, you can secure private cloud, great. If you're not paying attention, it can be weak. Public cloud, you probably, and honestly, a lot of times, it's probably better in the public cloud, because these are very large organizations who just do this for a living, and they manage this very well. If you only have like one person on your cloud team and don't have any cloud security people, then maybe burst to like to kind of transfer that to somebody else. Okay, couple more questions here. Okay, so difference between, what initiatives are cloud providers taking to make sure the data on their servers is secure? I would say that if your data on their server is secure, it's like that they don't own the key. And that's where the key management comes in, is that, you may have the underlying infrastructure, and you may have like your platform on there, but you're also using your own encryption. You bring your own encryption, as we call it. And so they don't have the keys anyway. So it's just this anonymous block to them from a data protection standpoint. What unique challenges does third-party cloud integration present? So if you're kind of meeting like multiple clouds integrating, they don't necessarily play well with others. There are protocols to do that, but sometimes there's, expense or costs, either from a data or transfer or other types of things. But it's all APIs. And so it's actually kind of easy. And then it's about then protecting the credentials and make sure it's not exposed, and it's a good password. It's not something to get, so then it's about protecting credentials through those APIs and making sure those APIs are secure. Let's see, did I miss any? So 9 was difference between private and public. 10 was initiative for cloud providers. Are VPCs a good way to secure cloud environment, or are there more secure methods? I think that's kind of a, I always say secure from what? And so, virtual private clouds being able to the micro segmentation to isolate things, make it better, make it easier, lowers the surface area of attack. Yes, that is certainly an architectural technique that is very, very effective. But, if you are not making sure that the data is protected and you're using good credentials and the APIs are not secure, then it's irrelevant. So from architecturally, yes, that is the right way of doing it. What's your experience with your high-risk security module to protect data and the credential? Longer discussion on that one, but that's kind of the way of doing it. And then some, just like any other kind of service, some things are easier to integrate than others, but don't have time to kind of get into that. 5-minute warning. And then final question before I finish this is my last slide, by the way. How should we handle slight breaches? Is it worth redoing everything? That's one of the beauty, and I guess you're assuming if something goes wrong, if something comes out of trust, just blow it away and restart it. Yeah, it's easy to do depending on what thing. Now, unless you really, really want the forensics for it, then you isolate it, move it somewhere else, and then you have the forensics team go look at it and see what happened and pull data and learn from it and that kind of thing. Depending on what your goal is. We would certainly not just if something comes out of trust, we want to know why and we want to kind of get to it. But if you're doing the isolation and protection, then you may not have that as much. Let me finish this. I got 3 minutes left. Let me finish the slide. The takeaways are on the left-hand side is classic cloud security lines say of here's how you secure the cloud. Harden the host, harden the infrastructure, secure the networks, architecture, and the management plane. And that includes the credentials. And what they include are kind of my things on the right, which is protect the credentials, because that's the first way of getting in. That's the way in is with credentials. It's no longer a network based on connection. We go in the office, we plug in. Or, it's a network based on identity. Protect those credentials. Manage vulnerability and configuration. It's all about configuration management. There might be configuration drift that takes something into insecure without you even knowing it, pulling from something that may be an old image that has, that's out of patch level. That's where these posture management tools are so critical, is to know the state of it, because it's such a dynamic environment. It's real easy to get drift and you start to get out of and come insecure. And then protect the data and the privacy. And I'll use this little soapbox to say, when we talk about CIA, confidentiality, integrity, and availability, I always like to add safety and privacy to it, because privacy is not the same confidentiality. Privacy is the appropriate use of data based on regulation or consent of the person who gives it to you. And so it's a need-to-know thing. Confidentiality is protecting it from unauthorized access. They're somewhat of a different thing, a different mindset. Okay, last question here. At what point is it important to communicate security threats to the large organization? Is it most beneficial to wait until the threat has been neutralized? This is part of your incident response plan and the culture of your organization, the size of your organization, how impactful that incident is. If it's a mild incident that's not potentially impacting business, then it might be okay, I'll roll it up at the end of the day and say, hey, this happened, we mitigated it, didn't affect anything, we did this thing, we fixed this so it doesn't happen again, cool. But if it's something that could be a mutual impact and you're still investigating it, and if that investigation could be something that could impact the organization, let leadership know. Because technical people don't make business decisions. And there might be decisions hey, we need to pull this thing offline to be able to fix it. And that's a business decision. And so I would say, and that's what's usually when you develop a incident response plan, you have these different gates of certain classifications of it. You identify an event. It could be elevated to an incident. The incident will have a classification. If it's a certain classification, which is based on different impacts to the business or sizes or number of records or et cetera, then there will be communications plans that align with that to be able to say, listen, someone has taken control of our email server. I'm not going to wait till the end of the day. I'm going to tell business right now, and then kind of go. So the more severe the incident, the sooner you communicate that to the business to let them know. And that's the end of my time, down to the very last wire. Thank you so much for your attention. Feel free to connect with me on LinkedIn. Whoops, I have slides here. Thank you very much for your attention, and have a great day and the good rest of the conference.